Hi everyone, let's discuss some special integrals today which will help us simplify our questions and thus our lives. So let's take a sneak peek into what I have in today's video. In the first part, we will discuss how to derive these formulas, and of course all the action happens in the latter part when we discuss the questions. So let's get started. Taking the first three integrals, let's discuss their derivations. Before we do that, I'm trying to recollect this tiny little table that we discussed during inverse trigonometric functions, which means if your function takes any of these forms, these are the respective substitutions you can make to simplify them. Let's try to recall and apply the same here. For instance, looking at the very first formula, which is 1 upon x square plus a square, look at the very first form. It resembles. Let's take x as a tan theta. So your dx becomes a secant square theta d theta. Now if you can recollect integration by substitution method, this becomes integral of 1 upon a square tan square theta plus a square, and in place of dx I have a secant square theta d theta. This further gives us 1 upon a sec square theta, and this one also becomes 1 plus tan square theta, that is sec square theta again. It gets cancelled and you get 1 by a into theta plus c as the answer. Remember, do not forget to replace back the value of theta from here, which would be tan inverse of x by a plus c. Those of you who do not know how we solve the questions using integration by substitution, do check out my playlist on integration, which you will find in the description box as well as by clicking on the I button. So, this is the final answer. Let's have a look at the second one and try to pick the relevant formula. So here I can put my x as a secant theta or a cosecant theta. So let's say I put x as a secant theta, then my derivative becomes a sec theta tan theta into d theta. So the integral now changes to a sec theta tan theta d theta on the top, and my denominator becomes a square secant square theta minus a square. This stays secant theta tan theta d theta. Here if I take a square common from my denominator, I'll be left with secant square theta minus 1, which is tan square theta. One of the tans, this is tan theta, one of the tans get cancelled and we are left with 1 by a. On changing this to sine and cos, this becomes 1 upon cos theta, and here we have sine theta by cos theta. So we finally get the answer 1 upon a cosecant theta d theta. If you recollect, the integration of this was 1 upon a log mod cosecant theta minus cot theta plus c. Now we have to replace back our theta. So for that, you know your secant theta has been given as x by a. So using your trigonometry, secant theta becomes h by b. So this is x by a. From here, your cosecant theta becomes h by p. So I get x upon under root of x square minus a square, and cot theta is b by p, which will be a upon under root of x square minus a square plus c. Now taking the LCM, we further get 1 over a log of under root of, we'll be left with x minus a upon x plus a plus c. Now here it's very simple. This square root could also be written as raised to power half, and as per the property log x raised to power n is n log x. So this becomes 1 upon 2a log mod x minus a upon x plus a plus c. This is the required answer. Now in the books you can find different kind of proofs where all this could be done by splitting, by partial fractions. However, I find trigonometry very convenient and does this method. Please go through the proof. Likewise, for the third integral, you can try substituting x as a sine theta, follow the similar process, and in the end, you would get this answer. Please try it yourself. Now look at the remaining three kinds. They are very similar, and at the same time, if you see, the only difference is of the square root. However, the formulas are going to be very different. So, for the first part, looking at the table, we can again substitute x as a sine theta. This leads us to dx as a cos theta d theta. So, your integral changes to a cos theta d theta whole upon square root of, this will be a square minus a square sine square theta. Now, this is a cos theta d theta. If you take your a square common inside, it comes out as a. We'll be left with 1 minus sine square theta, which is cos square theta, comes out of the square root as cos theta. Everything gets cancelled. The answer is theta plus c. Putting back the value of theta from here, it becomes sine inverse of x by a plus c, and this is our answer. So, coming to the fifth derivation here, as per the table that we just discussed, you can put your x as a secant theta. Now dx becomes once again a secant theta tan theta d theta. So the integral gets transformed to, this is the new integral. The denominator gives us secant square theta minus 1, which is tan square theta, comes out of the square root, becomes tan theta. These a's anyway get cancelled. The answer would be log mod sec theta plus tan theta plus c. We apply a very small trick before we substitute back the original function. So that is that we convert tan theta into square root of secant square theta minus 1. How does that save our time? Because now your secant theta is x by a, and I can use the same over here plus c. This becomes log of x by a plus under root of x square minus a square upon a square plus c. Now if you look at it, if I remove the square root sign from here, it is only a. So we can combine the two. This becomes log mod of x plus under root of x square minus a square. This could be taken out as minus log a plus c. I can combine the two and the final answer becomes x plus under root of x square minus a square plus some c1. This is the answer. Likewise for the sixth one, when you put your x as a tan theta, you would end up getting this answer. So these are the 6 special integrals that we have. Now how do we remember this would be a question. If you first of all mark and see that these two are the exceptional ones, where the answer is directly sine inverse x by a plus c and 1 by a tan inverse of x by a plus c. If you look at this one, we already know integral of 1 plus x square was tan inverse x plus c. So in place of that, if I put a square, this becomes a, and at the same time I get an extra a outside. So it's very simple to remember, and if we have already taken the tan inverse form with this, then that means with the square root we are only left with sine inverse x by a plus c to remember. Now talking of second and third, they resemble so much. First of all, 1 by 2a log is something which is common to both of them. We'll try to remember this part as per a. So in the first one, since a has a negative sign in front, So I take x minus a upon x plus a, whereas here my a has positive sign in front. So I take a plus x upon a minus x. Now similarly for 5th and 6th, both the square root kinds, it's very easy. You know it is log and log over here. Inside you are writing x, and then all you need to do is plus, and you are repeating the same square root over here. So go through them, find your own ways, but make sure you remember them before you start the questions. Now, before we start solving the questions on this, there are two things which are extremely important, which means x, here x that we are talking of in all the formulas actually symbolizes any linear function with coefficient 1. So that's the standard form, and the numerator, if you check out in each of these formulas, is always 1. Keep these two things engraved in your mind as we go along the questions. So beginning with the very first question, which is first of all without the square root sign, it is 4 plus 9x square. Now as we discussed, the numerator should be 1, which it is. Also the coefficient of x should be 1. So what I do is I take this 9 common, and we are left with 4 by 9 plus x square, which means this is 2 by 3 whole square plus x square. Now, if you look at the list, this is 1 upon a square plus x square, or x square plus a square. So it becomes 1 by a, which is 1 upon 2 by 3 into tan inverse of x by a plus c. On simplifying, you get 1 by 6 tan inverse of 3x by 2 plus c. Now few students don't enjoy this arrangement, and rather what they do is they write this as 2 square plus 3x whole square, and now they apply the same formula, which is 1 by a into tan inverse of x by a, but as we discussed earlier, that coefficient of x has to be 1. So in case you have already integrated with some other coefficient, then you know you need to divide with the same number, which would be 3. So it once again gives you 1 by 6 tan inverse of 3x by 2 plus c. Now both the methods are acceptable. Suit yourself and try out the questions. Now look at the second one. As I had just mentioned, I find it more convenient if I take this 16 common. So I'll be taking this 16 common. It comes out as 1 by 4, and inside we are left with x square plus 25 by 16, which gives us x square plus 5 by 4 whole square. Now this time there is a square root sign. Don't mix the two formulas, and thus looking at the list over here, you get log mod x plus, and you repeat the same, which is x square plus 25 by 16 plus c. And if you wish to take the LCM, you may do that, or you can even leave your answer here. Look at question 3. Though we'll discuss this concept in our later videos, that degree of numerator should be always less than the degree of denominator before you start doing any operation. However, in case the degree of the numerator is greater than or equal to degree of the denominator, then you can always apply long division, or if you can do it mentally, then go ahead and split this. So if I apply the long division here, this gives us x square, which is x raised to power 4 plus x square. So we are left with 1 minus x square. Now further I take this as minus 1. So this becomes minus x square minus 1. And on subtracting, you get 2, and this one gets cancelled. So now you know this is your quotient plus the remainder upon the dividend. This is how it gets split. So this is what we get. Now it is very simple. The first part simply gives you x cubed by 3. 1 has the integral x, and this one 2 comes out as it is, and here I apply this formula. I get only tan inverse x plus c. Here a is 1. Oh no, how will I apply these formulas to this kind of a form? If you actually try to look at it, the numerator is anyway 1. However, the denominator doesn't take that kind of structure. If you remember, we said x has to be any linear function with the coefficient of x as 1. So if I try to complete the whole square, our job will be done. For completing the whole square, once again, making coefficient of x square as 1, I take 9 common. So we are left with x square plus 6 by 9x plus 10 by 9. Now this is nothing but 2 by 3. Now in order to complete the whole square, if you remember, you always take the coefficient of x, which is 2 by 3 in this case, half it, so you get only 1 by 3, and then add and subtract its square. So here that means I'll be adding 1 by 9 and subtracting 1 by 9 to complete my square. Taking only this portion, we get x plus 1 by 3 whole square, and here if you subtract, this will be 9 by 9, which just gives us 1. So now now it's simple. This is a linear function with coefficient of x as 1 and numerator was anyway 1. So now applying the relevant formula, we get 1 by a, which is simply 1 this time, tan inverse of x by a plus c. On simplifying, we get 1 by 9 tan inverse of 3x plus 1 by 3 plus c. Now look at your fifth one. Once again we can complete the square, but before that, keep in mind I want to keep my coefficient of x as 1. Here x square has it as minus. So we can take this common. So the square root becomes x square minus 3x minus 8. Now one word of caution. We are taking this minus sign common inside the square root sign only and not taking it out, because we all know square root of minus 1 is iota. So we cannot take it out. We'll just keep it inside and complete the square. Now the coefficient of x is 3. So I take its half and then I take its whole square. So that gives me 9 by 4. So I know I have to add and subtract 9 by 4. This part gives me x minus 3 by 2 whole square. We get minus 41 by 4. Now before we do anything, we need to realize we have the formula for 1 upon under root x square minus a square, not when there is a minus sign. Now for our convenience, we multiply inside with the minus sign. So this gives us dx upon under root of, we multiply the minus sign, this gives us root 41 by 2 whole square minus x minus 3 by 2 whole square. And that's it. We have our formula, which is 1 upon under root of a square minus x square, ready with us. So the answer would be sine inverse of x by a, which is root 41 by 2 plus c. On simplifying, we get sine inverse of 2x minus 3 upon root 41 plus c. Please note the DIY questions. I know they are slightly tricky, but then that shall keep you motivated to check out my upcoming video, which will have the solutions to these. So keep watching. If you found it useful, hit the like button, share with your friends, and do not forget to subscribe to my channel. I would see you with the next video real soon. Till then, bye-bye.